In this class, we will learn how to integrate the system view with the RTOS. Till then, we have learned how to create the system view folder and subfolders and copying of the necessary files for establishing the communication between the target source and the host machine. Now we need to do little bit modifications in the files which we copied. First, we can see that the Segger system view config file. So there is no modification is required. Second one, Segger system view config free RTOS. So here we can give the application name what we are developing. So I am giving that the LED toggling for our first experiment, and the device which we are using Cortex M7, and the RAM address we want to start or we want to allocate for the system view. So the RAM base change to 2 from 1. So with this the file upgradation is over. Then save this file. Next we will go to the Segger system view freeautos.h. So in this header file we are not going to modify anything, but we have to add this file at the freeautos config.h file. So you have to select this file name, Segger system view freeautos.h, copy, open your freeautos config.h, go to the end of the file, and here you can give include Segger system view freeautos.h as per the guidelines. After adding this one, we have to go to the Segger system view defaults. In this file we have to look for that the system view core. So here we identified that for Cortex M3, M4 and M7 the core CM3 must be used. So select this CM3 and copy here Segger system view core other. In place of here other, you can paste this one. So save the file, and Segger system view Segger rtt.h. If you open this file, no need to modify anything here also. Segger sysview.h. So here also we need not to modify anything. The Segger RTT configuration, so we can set the buffer size, RTT buffer. So the RTT buffer is the communication between the target source and the host machine. From the buffer, the host machine will collect the data supplied by the target. So we are increasing from 1 megabytes to 8 megabytes. So default is 1 kilobytes. So we are going to change it to 8 kilobytes. Save this one. Now the modification of the files are over. Now we need to do the patching. So for the patching, you need to remember what is the path in the RTOS to be modified. So here if you open this RTOS patch file, so the supplier has given that the file names are like this. In the origination folder, config folder, FreeRTOS config.h is available. But in our case, the FreeRTOS config.h is available in the RTOS itself. So we are going to modify this RTOS folder. Oh, you can remove these directories, and we can directly modify the FreeRTOS config.h, because we are modifying the RTOS folder, and the FreeRTOS config.h is available within the RTOS. And second, we are modifying the FreeRTOS.h. So this is available in our project under include. So we have to remove all these prefixes. Now include FreeRTOS.h is selected. Similarly, we have to go to that task.h, we have to modify, and the task.h is also available in the include directory. So we need to remove the prefix path. This path is removed. So task.h is available right now, and here the CM0, Cortex M0, Cortex M3 and Cortex M4F is given. We need to modify this Cortex M4F as per the path in our directory in our project implementation. So here this is the default path provided by the Systemview supplier, the org, FreeRTOS, source portable, GCC, and the port C is located in his environment like this. But in our environment, the program is available at port CD is available at portable, GCC, ARM, CM7, R0P1, and here these two files are available. So we have to modify this path. So remove the folders, then keep the portable, GCC, ARM, CM7, it's not ARM CM4F in our case, ARM CM7, and we need another level of directory, so include that one, R0P1, and here the port C is available. Similarly, copy the same path, copy and paste it here, because the port macro.h is also available in the specified path. So finally you need to modify this task.c. So whereas task.c is available for us under the RTOS folder itself, so we need to remove these folders and task.c. So we have completed the modification of file path as per our directory or as per our project explorer. Now save the patch file and select the folder which you want to modify. So we are going to modify this RTOS. So right click and go to team, apply patch. So here first we have to select from the workspace where the patch file is available. So this is the patch file available under Systemview in the patch folder. So select the file and select the folder which you want to modify. So we are going to modify RTOS. So it was by default selected. Select next. This will give you that what are the files are going to be modified, patched, and what are the things we are going to modify. Then select finish. So after the modification, what you have to do is you have to build the project. So the 0 errors and 3 warnings. After that, we need to modify the main file. for making use of this system view in our project. In the main file we have to add two commands. One is segger system view config, this one, and after that we have to add another folder, another command, segger system view start. So by adding these two commands, the system view is going to be integrated into our RTOS application. After adding this, we have to modify the MSP folder. So in the source, HAL MSP microcontroller support package MSP initialization. In the MSP initialization, we have to integrate this command, that is NVIC set priority grouping to 0. So the command belongs to the CPU assignment to the tasks. We will see it later. So now the configuration of system view is over. Now build the project. We got 0 errors. Then go for the debugging. It will download the project into the target and run the program. Next, launch the system view application on the host machine. Accept. Okay. Go to the target, select start recording. Accept. Now it is showing that how the tasks are running and how the CPU is scheduling the tasks continuously. So this can be observed from our system view. So all the tasks and their time stampings, how the context switching is happening, everything can be monitored now from the system view. Thank you for watching.